Hi everyone, in this tutorial we work through an example in which we solve a linear differential equation using the integrating factor. We're told to find the general solution to the differential equation shown here. That is x cubed times dy dx plus 2x squared times y, which equals to 24x. Before solving this, I should say that we can tell right away that this differential equation is a linear differential equation just by quickly comparing it to what I would call the standard linear ordinary differential equation. And the fact that it's a linear differential equation is exactly what tells us, or what should trigger us to, use the integrating factor. That being said, let's see how to solve this. We can summarize the method for solving this equation in 3 steps. The first step, and I'll go ahead and write step 1, is to get rid of anything multiplying the dy dx. So here we need to get rid of this x cubed. The objective being to write our linear differential equation in the form dy dx plus p of x times y equals to q of x. So that's our target, and to get there, all we have to do is divide the left-hand side as well as the right-hand side of this equation by x cubed. Doing so leads to dy dx plus 2x squared divided by x cubed, which is 2 over x, and that multiplies y, and that's equal to 24x divided by x cubed, so that's 24 over x squared. Now that that's done, we move on to step 2. And in step 2, we need to find the integrating factor. So I'll write find the integrating factor. Okay, we usually call the integrating factor capital I of x, and to find it, we use the fact that it's equal to e of the integral of p of x. Where, to be clear, p of x is the function multiplying y inside our differential equation. So for the example we have here, p of x will be 2 over x. So I'll just write that, that's p of x. So for this example, I of x is equal to e of the integral of 2 over x, and that's equal to e of 2 times ln of the absolute value of x. Notice here that I haven't written a constant of integration, and that's because when we look for an integrating factor, we ignore the constant of integration altogether. With that in mind, I carry on, and I place this 2 that's multiplying the logarithm as an exponent on the x inside it. So that's e of ln of the absolute value of x squared. And assuming here that x can't be 0, since ln won't be defined in that case, this x squared will always be positive, so I can get rid of this absolute value. In other words, this becomes e of ln of x squared. Finally, using the fact that e and ln are inverses of each other, we can state that the integrating factor I of x is equal to x squared. And I'll go ahead and box that result. There we go. I now move on to the third and final step, in which I multiply the differential equation that we have here by the integrating factor x squared, and then using the product rule, I solve the differential equation. So I'll just go ahead and write multiply, let's multiply dE as in differential equation by the integrating factor I of x, and use product rule, and solve. And here's how that works. Multiplying this differential equation by x squared leads to x squared times dy dx plus 2 over x times y times x squared, which becomes 2x times y, and that's equal to 24 over x squared times x squared, which is just 24. And now, looking at the left-hand side of this equation, we see the whole idea behind using the integrating factor. Indeed, we know that x squared is I of x, that's the integrating factor, but on top of that, we notice that 2x is in fact the derivative of x squared. In other words, it's di dx. And since I is multiplying dy dx and di dx is multiplying y, we quickly see that what we're dealing with here is the product rule. In other words, the left-hand side of this equation is in fact the derivative with respect to x of the product of x squared and y, and that's equal to 24. And before carrying on, let me stop for a second just to say that when you use the integrating factor to solve a linear differential equation, the left-hand side of the equation should always turn into the derivative of a product of two functions. If ever that's not the case, then something must have gone wrong and you should go back and check your working. That being said, I carry on. To solve this, I integrate both sides of this equation with respect to x, which leads to x squared times y equals to the integral of 24. That becomes x squared times y, which equals to 24x plus some constant of integration, c. Finally, dividing both sides of this equation by x squared, we find that the general solution is y equals to 24x plus c over x squared. And that's the final answer. And so, using the integrating factor, we've just solved the differential equation that we were given here. And that's it for this tutorial.